In this lesson on polynomials, we'll do some additional examples using long division to divide polynomials. Here's our first problem. We have the fifth degree polynomial 2x to the fifth plus x to the 4 minus 6x plus 9 divided by x squared minus 3x plus 1. So we set up our long division, and notice I've left some space here since our fifth degree polynomial does not have an x cubed or an x squared term. This will help us when we're doing the long division process. So we look at the leading term of the polynomial we're dividing by, which is x squared, and we say how many times does x squared go into this leading term 2x to the fifth. It goes in 2x cubed times, so then we multiply and we get 2x to the fifth minus 6x to the 4 plus 2x cubed. And now we subtract. 2x to the fifth minus 2x to the fifth gives us 0, so that goes away. We get x to the fourth minus 6x to the fourth, which gives us 7x to the 4. And then we don't have any x cubed terms in our original polynomial, so we get 0x cubed minus 2x cubed, which gives us a minus 2x cubed, and then our minus 6x plus 9 comes down. So next we look at our x squared and say how many times does x squared go into 7x to the fourth. It goes in 7x squared times, and then we multiply. So we get 7x to the 4 minus 21x cubed plus 7x squared. And again, we'll subtract. So 7x to the 4 minus 7x to the 4, those go away. Minus 2x cubed minus minus becomes plus 21. So that's 19x cubed. We don't have any x squared terms in the top polynomial, so we get a minus 7x squared, and then our minus 6x plus 9. Next we say how many times does x squared go into 19x cubed, so we get plus 19x. Multiplying, we get 19x cubed minus 19 times 3 gives us 57x squared plus 19x. And then again we subtract. The 19x cubed terms go away. Then we get a negative 7x squared. Minus minus gives us plus 57, so that's 50x squared. Minus 6x minus 19x gives us a minus 25x, and then we get our plus 9. So next we say how many times does x squared go into 50x squared, so we get a plus 50, and multiplying down we get 50x squared minus 150x plus 50, and finally subtracting now, the 50x squared terms go away. We get minus 25x minus minus gives us plus 150, so that's 125x. 9 minus 50 gives us minus 41. X squared does not go into 125x, so our remainder now is 125x minus 41. So we found that x squared minus 3x plus 1 goes into 2x to the fifth plus x to the 4 minus 6x plus 9, 2x cubed with a quotient of 2x cubed plus 7x squared plus 19x plus 50, and a remainder of 125x minus 41. Like we've done previously, let's look at the various ways that we can express this fact. So when we divided 2x to the fifth plus x to the 4 minus 6x plus 9 by x squared minus 3x plus 1, we got this quotient, 2x cubed plus 7x squared plus 19x plus 50, and a remainder of 125x minus 41. So this tells us that 2x to the fifth plus x to the 4 minus 6x plus 9 over x squared minus 3x plus 1 is this quotient, 2x cubed plus 7x squared plus 19x plus 50 plus 125x minus 141 over x squared minus 3x plus 1. And we can rewrite that, multiplying both sides by x squared minus 3x plus 1 as our original degree 5 polynomial is equal to the polynomial we divided by x squared minus 3x plus 1 times this quotient that we obtained when we did the long division plus the remainder 125x minus 141. In our next example, we're dividing 3x squared minus 13x minus 10 by x minus 4. So again, we look at the leading terms. X goes into 3x squared 3x times, and we get 3x squared minus 12x. Subtracting, the 3x squareds go away. We get minus 13x plus 12x, which gives us minus x, and then our minus 10 comes down. X goes into minus x minus 1 times, so we get minus 1. Multiplying, we get minus x plus 4. And then we subtract. Minus x minus minus x goes away. Minus 10 minus 4 gives us minus 14. And x does not go into minus 14, so we have a remainder here of minus 14. And again, how can we express this fact? So we know that when we divided 3x squared minus 13x minus 10 by x minus 4, we got a quotient of 3x minus 1 with a remainder of minus 14. We can write that as 3x squared minus 13x minus 10 over x minus 4 is 3x minus 1 plus this remainder negative 14 over x minus 4. Multiplying both sides by x minus 4, we have our original polynomial, 3x squared minus 13x minus 10, is the polynomial x minus 4 that we divided by, times the quotient that we obtained with long division, 3x minus 1, plus our remainder, which in this case is negative 14. So let's do one more example with this same polynomial. So here we're going to divide 3x squared minus 13x minus 10 by x minus 5 instead of x minus 4 and see what happens. So again, x goes into 3x squared 3x times, and we get 3x squared minus 15x. Subtracting, our 3x squareds go away. Minus 13x minus minus becomes plus 15x, so we get 2x minus 10. X goes into 2x 2 times, so we get plus 2. Multiplying, we get 2x minus 10, and subtracting, 2x minus 10 minus 2x minus 10 gives us 0. So x minus 5 goes into 3x squared minus 13x minus 10 evenly. We have a remainder of 0. So this tells us that 3x squared minus 13x minus 10 divided by x minus 5, we got this quotient of 3x plus 2 with a remainder of 0. Or 3x squared minus 13x minus 10 over x minus 5 equals 3x plus 2. And again, notice we don't have a remainder term here because our remainder was 0. Multiplying both sides by x minus 5 gives us that 13x squared minus 13x minus 10 is equal to this polynomial x minus 5 that we divided by times our quotient, 3x plus 2, and in this case, our remainder was 0, so we just have a plus 0 or nothing on the end. So what we observe here, we obtained a remainder of 0 when we divided by x minus 5, and what we found is that x minus 5 is a factor of 3x squared minus 13x minus 10. So we ended up with a remainder of 0. In other words, we were able to factor 3x squared minus 13x minus 10 as x minus 5 times 3x plus 2. In our previous example, when we were dividing by x minus 4, we did have a remainder, a non-zero remainder, so x minus 4 was not a factor of 3x squared minus 13x minus 10. And we'll explore this concept in more detail as we move forward.